Good day everyone. In this video, I will going to discuss to you on how to perform laboratory exercise number 1, that is tensile test. We are going to use a simulation tool to run this test, and that is our SolidWorks software. In SolidWorks software, first we are going to model our specimen, and then we are going to run the simulation, and finally we are going to analyze some important parameters for our specimen, that is the stress, the displacement, and finally the strain. To begin with, so you need to launch your SolidWorks software, so as you can see on the screen. And the next is we are going to choose we're going to click this one at the upper left, and then press the new button, and then here, since we are going to create our specimen, so choose the part and then press OK. So this is our working area of the SolidWorks software. First is we're going to create a 2D sketch of our specimen. So in creating our 2D sketch, you need to choose the desired plane that you're going to draft, or yeah, that you're going to create your sketch. So for me, I'm going to choose the front plane. So click the front plane and then click this sketch icon, and after that the front plane will uh, will display normal, no normal to the uh, working area. So to begin the sketch, in your keyboard, press the S button and then choose this one for the line, and then start your sketch with a vertical line, so from the origin and then to the upper direction, to the vertical direction. So there you have it. You have already the vertical line, and then next followed by a horizontal line, and then another vertical line which is shorter from the previous, and then another horizontal line, and finally change the line types by pressing again the S keyboard. In your keyboard, press S, and then instead of the solid line, change this one into a center line. So after you change the line type, so start the new line type from the endpoint, and then terminate that one to the point that is aligned to the initial point or aligned at the origin. Uh, you can also have that one, no, by looking at the guidelines. We have here some guidelines shown by these hidden lines colored in blue. So once aligned, so hit that one, and there you have this construction line. And after that, change again the line type into solid, and then from the endpoint going to the original point or at the origin. And then after that, press S, and then we're going to add dimensions of our specimen, or our sketch. So press this smart dimension icon, and then for this vertical line we're going to set this one equal to 15 mm, and then this is equal to 30 mm. So this 30 mm represents our width of our grip section, and then half of our specimen measures 63 mm, and then half of the cage area measures 7 mm. Okay, so in this corner we are going to create a fillet. So I will construct a a line that would locate the center of my fillet curve. So going to end this at here, and then I'm going to add some dimensions. So press S, smart dimension, and the length of this construction line is 8 mm. And after that, I'm going to create, so press S, and then create a center point arc. So press the center point arc, start at the center, and then from this point, then create an arc. So if this happens, so just turn the arc in this direction. Okay, this one. So terminate here, just terminate here. So it indicates that A is equals to 90 degrees, or the arc covers a 90-degree angle. So press that one, and then there you have it. So you have this one, and then we're going to trim this. So press S, then hit this trim entities, then trim this one. And after that, our sketch, so press enter, or you can also press this one equal sign in order to terminate the trimming process. And after this one, so our sketch is already fully defined. So since this is just the half of our specimen, so we're going to mirror this sketch by this or along this axis. Okay, so to do that, press this one, mirror entities, and then entities to mirror. So select this vertical line, this horizontal line, this arc, this one, and this one, and then we're going to mirror about this line. Okay, so of course we need to copy the original sketch, and after that, press OK, and then we have now the sketch of our specimen. And then to generate the solid form of our specimen, so press this feature tab, go to features tab, and then choose revolve boss or base. And then after that, choose the axis of revolution. So we're going to revolve, or we're going to rotate this sketch about this horizontal line, and then it automatically selects. But if it will not automatically display some preview, you can also select the contour. So you can choose this one, and that's it. Then press OK. So this is now the final form of our specimen. As you notice, we have a bigger cylinder at both ends, and we have this smaller cylinder at the middle. So this smaller cylinder is our gauge length, while these two smaller cylinders at the end points, or at the ends of this specimen, is our uh, grip section. So in the actual universal testing machine, so this one is securely attached at the universal testing machine. So next, we are going to uh, proceed the simulation. In order to activate the SolidWorks simulation add-ins, so you can press this one, SolidWorks add-ins, press this, and then choose this SolidWorks simulation. So click this one, and then it will load for some time. So be patient, just wait. And then okay, finally it was already activated. So you can only say that it is already activated by looking at this one. So uh, the simulation tab will appear right next to this SolidWorks add-ins. So this is this is the menus for the simulation. If you cannot see this SolidWorks add-ins, no, in your tab section, So another way of activating this SolidWorks simulation software is by accessing this option icon. So under option, so click this drop down arrow and then choose add-ins, and then in the add-ins tab you're going to choose the SolidWorks simulation. So check this one and also this, and then press OK. So that's the other way of activating the simulation feature of SolidWorks. So now we already have the simulation add-in. So the next thing that we're going to do is um, go to the simulation tab, and then under study advisory we have here a drop down arrow, and then choose new study. So for our tensile test, we are going to conduct a non-linear study. So this is the appropriate study for performing a tensile test. So choose non-linear, and then choose this one. Instead of static, we're going to use dynamic because we're going to stretch our specimen. So hit dynamic, and then after that press OK. So we are now, as you can see on the status bar below, so we are now on the nonlinear one status, meaning we are about to perform the simulation. So under the simulation, so under this tab, no, on the left, so we are going to um, edit some information. First is for our specimen for the material. So uh, press this one and then right click and then apply edit material. For our study, we are going to choose a predetermined material. So click this SolidWorks material, click this one, and then choose steel. So under steel, we're going to select plain carbon steel. So this is the these are the properties of a plain carbon steel. We have here its elastic modulus, Poisson's ratio, shear modulus, mass density, tensile strength, so on and so forth. For our tensile test, we are going to select plasticity von Mises. And after that, hit apply. And once you hit apply, so it will automatically update the material of our model, and then press choose close. Next, for the connection, so we don't have this one because we do not have any parts. We only have one model, one specimen. So do not worry with this section. So let's proceed to the fixtures. So for our uh, fixtures, so right click this and then add a fixed geometry fixture, because in the actual universal testing machine, so one of the grip section will be fixed and the other is allowed to move or to displace. So for our fixed geometry, so here we're going to choose the surface that we're going to uh, make it as a fixed or as a stationary. So we're going to choose this left grip section, and then after that press OK. Next, aside from the fixed geometry, we're going to right click fixtures and then add advanced fixtures. In the advanced fixtures, go to the on cylindrical faces. So select this on cylindrical faces under advanced, use reference geometry. So on cylindrical faces, and then in this blue box we're going to select this one. So this will be our um entity that we're going to displace. So here under translation tab, the unit should be in mm. So we are going um, to translate this one. So since this is a tensile test, so we're going to move the specimen actually. So choose this one and then input 20 So this is our set displacement of our specimen. Okay, so again, we don't have radial. No, we don't have radial, so that is 0. So we only have eggshell displacement. So for our eggshell displacement, make sure that the direction of the eggshell displacement is going to the right. So as you can see this arrow. So if in your SolidWorks software, if it is in the opposite direction, so just check this one. Check this reverse direction, and it will reverse. No, it will change its direction. So let's uncheck this so that our translation will be towards the right. And after that, press OK. So we already um, set the fixtures or specimen. And then next for the external load, so we don't have it because in this test we are only inputting the displacement of our specimen. So the next step is go to the mesh section. So under mesh, right click, and then we're going to create a mesh for this specimen. So since we have fillets, so go to the mesh parameters, and then instead of the standard mesh, we're going to use curvature based mesh because of the presence of some curves here, no, because this is a fillet curve. And after that, choose OK, and then it will automatically generate the mesh pattern of our specimen. Next is we're going to run the simulation, but before that, go to the study advisory, press the drop down arrow, then go to the study properties. So under study properties, we're going to make some modifications of its settings. So under geometry non-linearity options, so check the use large displacement formulation and also the large strain option because we treat the 20 as a large displacement. And for nonlinear test, it is desired to select a solver that would run this simulation. So we use large problem direct sparse and then hit OK. And afterwards, uh, right click this nonlinear one default section, or you can also right click this, or I mean you can also right click this and then mesh and run, but um, you can also right click this one. So to make the process simpler, you can also right click this nonlinear one default and then run the simulation. So here there is another um, dialog box that has opened, so just press OK, and then here we have the dialog box for the um, timeline or the progress of our simulation. So the elapsed time of our simulation depends on the specs of your PC or laptop. So it will take longer time to run this simulation, especially for non-linear study. So be patient, and then while waiting, no, while waiting, try to observe also the changes that will happen or will occur to our specimen. So at this moment, the progress is 0.5%. Okay, so I'll just pause the recording, and then I will update you every 20%, okay, of the progress of this simulation. Okay, so here's an update. At 0.6%, the display of the specimen changes from the mesh mesh appearance into this simulation appearance, wherein we can see some colors that indicates the magnitude of the stress that is experienced on a particular location of our specimen. So the red one indicates the highest stress experienced by our specimen. So it is normal, no, to experience the progress of our simulation. No, it is normal if you have a dropping value of your percent. So earlier we have 0.6, but now we are down to 0.4. So it's normal because from time to time, uh, this percent value will increase. So from 0 to 100%. As you can see, so the uh, the simulation time and its performance will depend on the specs of your laptop or PC. At the moment, we have a memory usage of uh, almost 600,000 kilobytes, and the elapsed time at the moment is 5 minutes. So we are now 5 minutes from the start of our simulation. So I will going to update you after 20% of the progress of this simulation. Okay, so after 22 minutes from the start of our simulation, so we are now at 20.8%. This is the progress. So this is now the appearance of our specimen. As you notice, the uh, the middle of our specimen experiences a necking effect, wherein its cross-sectional area decreases, and this happens at the midsection of our specimen. And at the midsection, we can see that the color here is red. It means that it experiences a greater amount of stress compared the uh, to the sides. Okay, so I will going to update you after or next 20% of the progress. So I'm going to change uh, some tabs here. So I will going to move this dialog box right here. Then I'm going to zoom out the model. So okay, so I put it right here so that um, the uh, the model will be clearly seen, as well as this label right here for the stress. Okay, so in our dialog box right here, so our current memory usage increases from that was 500 kilobytes. So now we are at around, we are now on 1 million kilobytes. Okay, after 45 minutes and roughly 15 seconds, we are now 60.8% of our simulation progress. As you notice, there is a drastic change of the cross-sectional area of our specimen. Okay, so let's wait for another minutes. I will update you when we reach um, 80% of our simulation progress. Okay, after 56 minutes and roughly 35 seconds, we are now 80.8% of our simulation progress, and our memory usage increases to roughly 2000 kilobytes. So my next update is when we reach our simulation progress to 100%. Now, at this moment, try to notice at the neck, no, or at the center, or at the midsection of our specimen. We have here a black line. So this is probably a crack, no, that propagates at the midpoint of our specimen. And now, after almost an hour and 7 minutes, the simulation progress is already 99.8%, and this is now the appearance of our specimen, as you notice at the necking area. So there are some uh, fewer black lines, so it indicates that there is a crack that propagates at the necking area. So our simulation is already 100%. So it means that the simulation process is already successful, or is already done. And let's wait for some time, no, to terminate the simulation process, so you can see that one if this dialog box will close. Okay, so it closes already, and now this is our simulation result. So first we are going to examine. So I forgot to save this, but let's just ignore this one. So let's examine the specimen. So I will going to rotate the specimen, okay, like this, and then we're going to zoom in this area. So we have here some fewer black lines at the neck area. Okay, and then let's zoom out again. Then we're going to position our specimen in this manner. Now this window shows the stress result. So the result for this nonlinear study has three uh, result parameters. We have the stress, the displacement, and the strain. So for the stress, actually um, we can label the maximum stress by right clicking the stress option, and then choose chart option. Okay, so it will load for some time, and then under display options you can check show the maximum annotation. So the maximum stress is at the center, no, maximum of 2.194, and this value is also similar to the value that is shown in this vertical label. So keep in mind that the yield strength for this material is 2.206 times 10 to the power of 8, which is greater than the maximum stress displayed in this specimen. Okay, and once you're done with this, press OK, and then under the stress result you can also animate this one. So again, right click, choose animate, and under the animation section, so you can create an animation. So as you notice, our specimen is under animation from its initial position up to its stretch form. Okay, so here you can save this one as a video file, then press option, but it will load for some moment. I think we need to browse na lang. We need to browse the location of our file. So let's name this one animation animation for stress result. Okay, after that, press OK. The next, let's proceed to the displacement. So to show the result for the displacement, press the displacement option and then right click and then show. So this is the corresponding displacement of our specimen. So you can also um, insert the maximum displacement now by right clicking the displacement option, then uh, choose chart option, and under display option, check the maximum annotation, show max annotation, then press OK. And similarly, with the stress, you can also animate the displacement result. So under the animation section, so you can save this file. So press this one, and then let's write animation for displacement result. Press enter and then press OK. Next, let's show the strain result. So click the strain option, then right click and then show. This is now our strain result. So the same with displacement and stress. Right click, then select chart options, and then check the show maximum annotation to show the maximum strain, and press OK. And then we're going to apply some animation. So save file as AVI, then browse the location. So animation of strain result, save, and then um, press OK. Press OK. So after showing the result, we can also um, we can also export a document that contains the full details of the result of this simulation. Okay, to generate the report, so click or select this report option, and then under this report option we can also add some image for our report. So you need to right click this one and then include image, and then you can select either image file or the current view of our working area. So this is our working area. So you can also have this as a as an image of your result. So press OK. And then next, in generating the final document for our simulation result, so just right click the report uh, section, or the report option, and then define, select define, and then it will load, and then the yellow box will show. So the report sections, these are the contents of the reports: load and fixtures, connector definitions, mesh information, result summary, conclusion, so on and so forth. So you can also input here the name of the designer, the company, the URL, the logo, the address, so on and so forth. But for this video, let's just publish this one directly. But before that, let's change the paper size from letter to A4. Okay, and then the report path, now it's up to you. So let me change this one, no? So I will just put the report at the desktop. Under desktop, MEng 143 laboratory reports, lab exercise number 1. Press OK. And then again, instead of letter, I'm going to use A4. Apply, and then published. It will load for some time, so be patient. So as you can see right here, there is a dialog box showing the generation of the report. So we're now 22%. So just wait for some time, because the software is still processing the report of the simulation. Okay, so we are now 83% of the progress in generating the report. So it's already 89, 94, and then okay, so it will automatically direct you um, to the file of the simulation report. So we have here the simulation the file name um, of our model. So the date, the designer, study name. So the study name is nonlinear analysis. This is nonlinear dynamic, and these are the contents. So it's just a run through with the result. So this is the model information. So we also have here some information of the mass of the specimen, the volume, the density, because we assigned the type of material for our specimen, that is plain carbon steel. So for the study properties, these are uh, the uh, the properties, no, and the parameters during the test, during the simulation. So we have here the mechanical properties of our material, and then some component forces, the resultant forces. Then next, the mesh information. So we have a curvature based mesh. Then the total nodes and total elements are shown in this table. So this is the meshed model, and then these are the results. The first one is the stress. So uh, it displays the minimum and maximum stress, and then next followed by the displacement, and finally the strain. Okay, so I think that's it for this video. So for your laboratory exercise number 1 write up in your discussion, so just examine and observe the changes that happens in our specimen as it displaced from 0 to 20 mm. But before I end this video, I will play the uh, the animation for each result parameters. Okay, so for the animations of each simulation results, let me start with the stress parameter. So this is the animation for the stress result, and this one is our displacement result. And lastly, this is our strain result. Okay, so that's it for our laboratory exercise number one, that is about the tensile test, wherein our simulation tool is the SolidWorks software, and then the type of our simulation study is nonlinear and dynamic. So thank you for watching, and may God bless you.